Today's lesson is lesson 6.1, Graphing and Factoring. Today we're going to learn how to solve quadratic equations by graphing and by factoring. Remember, a quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c. This is our standard form. An equation, a quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0. Notice that the only difference here between our two forms is that we have f of x so that we can graph, and we have 0 so that we can solve. These are the only differences between the two. Over here in the graph is shown the function f of x equals x squared plus 2x minus 3. The x-intercepts, zeros, solutions, roots, and factors of this quadratic function are all related. Remember, all of these words mean the same thing. The x-intercepts can be found on the graph. They are the same as the zeros, the solutions, the roots, and the linear factors. I can use any of these words interchangeably throughout the lesson. They just simply mean these points right here on my graph. All right, so the x-intercepts of my function are located at -3 and +1. Notice -3, 0 and 1, 0. Because they are x-intercepts, we are going to write them as coordinate points. When I call them zeros of this function, I simply call them -3 and +1, like I first stated. These are the x values of the x-intercepts. Notice the x values of the x-intercepts. There they are, where my values of f of x is equal to 0. This is so that I can find them easily in a table. The linear factors of the function f of x equals x squared plus 2x minus 3 are x plus 3 and x plus 1. Remember, when we put into factored form, we have our two factors, x minus p and x minus q. So when I plug them in, x minus -3 is going to become +3, and x minus +1 will become x minus 1. This is where these linear factors are coming from. Notice that the signs in my linear factors are opposite from what the zeros are, and negative, and this one is positive. The solutions of my equation, now when I take the function and set it equal to 0, the solutions are -3 and +1, just like the zeros are. The solutions are my x values, where my function f of x is equal to 0, just like my zeros. The roots of my equation, notice once again, it's the equation, so we're setting it equal to 0, are -3 and 1. The quadratic equation is a root of a quadratic equation is another name for the solution of the equation. To solve a quadratic equation, ax squared plus bx plus c is equal to 0, by graphing, we need to find the x-intercepts of the related function f of x equals ax squared plus bx plus c from the graph. To do so, we need to make sure that the quadratic equation is set equal to 0. That way we can then replace 0 with our f of x and graph its related function. Then we can go ahead from our graph and identify the x-intercepts, and we can record our solutions. Let's go ahead and get started with our first two examples. Let me go ahead and zoom into part A. Question A, find all of the real solutions to the quadratic equation by graphing. At first glance, I can tell just by running a line through the equal sign that this is not equal to 0. Since my x squared and my 8 are over here on the left side, and there is only the 6x on the right side, I am going to move the 6x to the other side. Remember, when I move terms from one side of the equation to the other, I must cancel them out. To do that, I do the opposite operation of what they are. 6x is positive, so I will subtract it. I'm going to go ahead and put the 6x in the middle because I cannot combine it with the x squared. X and x squared are different terms. It's like buying a red apple or a green apple at the store. Yes, they are both apples, but one of them is green and one of them is red. All right, and of course the 8 does not have one. So I would rewrite it. I'm going to go over here. X squared minus 6x plus 8 is equal to 0. Now I can go ahead and I can graph this in my graphing calculator. I don't have my graphing calculator with me today, so I'm going to go ahead and use Desmos. I'm going to go ahead and put x squared minus 6x plus 8. And here I can see the graph in Desmos. I also can see right here the two x-intercepts, which are going to give me my solutions. If I wanted a more precise graph, I could also grab the vertex. Remember also that the axis of symmetry goes vertically through that vertex. Let me take the x-intercepts off. The vertex, the axis of symmetry goes vertically straight up and down through that vertex. And right up here, I do have my y-intercept. These 2 points here that you see on the screen are really just for graphing purposes to make my graph look better. The two numbers that I need from my graph right now are these two right here, 2, 0 and 4, 0. Let's go ahead and go back. There we go. Let's go ahead and go back to our graph, and I'm going to go ahead and put my two intercepts at 2, 0 and 4, 0. If I wanted to, I could place that, like I said, that vertex and then that that y-intercept 1, 2, 3, 4, 5, 6, 7, 8. There it was. Now I can go ahead and I can draw my graph. No, it should look like a U. Give me 1 second. There we go. And let me pull it on into position. Perfect. There's my graph. I need my x-intercepts to answer this question. From Desmos, I can see that they are at 2, 0 and at 4, 0. So what are my solutions then? What are my solutions? Well, one solution is x equals the 2 and there we go. The other solution is x equals 4. And that's it. Let's go ahead and try another example. X squared is equal to 9. At first glance, drawing my line through my equal side, I can see that we are not equal to 0. I am going to move the 9 over here because I do want to keep the x squared positive in my graphing. All right, so just remember when you're moving, you're going to go ahead. There we go. Hold on a second. There we go. Remember when you are graphing, you're going to want to make sure that you are set equal to 0 so that you can graph. All right, let's see if I can get my Desmos to come up. Hold on. And we can see it in the same screen. There we go. Perfect. I'm going to go ahead and get rid of this graph, and I'm going to go ahead and place into Desmos x squared minus 9. And I can see right over there on the right side of the screen my graph. I'm going to go ahead and grab my x-intercepts. There they are. Once again, just for graphing purposes, if you wanted to, you could get your your y-intercept, which is also your vertex for this one. But remember, that's just for graphing purposes to make your graph look nicer. These are the ones that my graph needs. So my x-intercepts, hold on a second. My x-intercepts are at the points -3, 0 and +3, 0. I could go ahead and graph them. Let me grab my color. Where's my color? There we go. -3, +3. And then we had, let's see, we had it at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. And there's our graph right there. Now, not as important as we are making the graph here in class that it be perfect, right? Not as important in class that we make it be absolutely perfect. But when we are testing and things like that, we're going to want to make sure that our graph is a little bit more precise. So this is why we would want to make sure that we do have that vertex, which is also our y-intercept graphed as well. This is going to ensure that any graphing system or graphing software is going to go ahead and graph for us properly. All right, let's go back to our assignment and our solutions then, because that's what this question is asking for. Our solutions then are x equals -3 and x equals +3. All right, let's go ahead and try 2 more. Find all real solutions for the quadratic equation by graphing. All right, just remember, you do want to make sure that you have your equation set equal to 0. A quick and easy way to do that is to draw your line down the middle. I can see that I have 2 terms on the right side, and I have 1 term on the left side. Could I move this one over here? Sure. But we normally, when we put our quadratic equation into standard form, we want to make sure that the a value, which remember is always with our x squared, is positive. So in this case, I am going to go ahead and move both of these to the other side. They're both going to go ahead and move. I would subtract the 14x because it is positive, and I would add the 49 because it is negative. So I'm going to come over here and do that, making my equation, there we go. There we go. Now I can, that was not a 0. There we go. Now I can go ahead and I can find my x-intercepts. I can already kind of prep that I know there's that somewhere at 0, and then there's another one at 0, right? I can prep that before I even start graphing. Let's go ahead and see if we can bring Desmos back up one more time. Perfect. Let's go ahead and put in our equation. Now remember, if you do have the graphing calculator available for you, you can use that as well. I'm going to go ahead and give Desmos just a little bit more of the screen because I'm noticing that it looks like Desmos is only touching the x-axis right here at 1 point. This means that I only have 1 x-intercept. So I'm going to go ahead and fix that on my notes. And it does appear that it is touching the y-intercept. My graph is stopping at 10, so I'm not going to worry about graphing so precisely this time. I'm going to go ahead and squeeze it over, bring back my, and I'm going to go ahead and erase this because there's not an and situation this time. There is only 1 intercept. 1, 2, 3, 4, 5, 6, 7. There it is. And my graph looks something like this. Perfect. Oops. Hold on. It doesn't want to squeeze down there. Here we go. There's my graph. And since it's just a sketch, it's perfectly fine to leave my graph like this. I'm going to go ahead and get rid of Desmos because I am done using it for now. Now that I moved Desmos, I think, there we go. All right, just a reminder, I've been talking about the axis of symmetry. This is that line, that axis of symmetry that's going through the vertex. This time, this point right here is not only the x-intercept or our solution, but it's also our vertex, which gives us our axis of symmetry. All right, so our solution this time, there's only one this time. Our solution is simply x equals 0. Remember, if you were going to write an equation, this is where we were writing in stuff like this, and we were giving it that square, right? When we were writing it in the equation in the last unit. All right, I encourage you to go ahead and pause the video and give this last one a try. All right, this one, as I can see, as I draw my line through the equal side, it is already set equal to 0. So I do not have to solve this one at all. I can simply go to Desmos and I can graph it. So I'm going to go ahead and show you that really quick. Let me see the equation. 30, there we go. Now in Desmos, I can see my two intercepts quite easily. Desmos does a wonderful job about showing me that. You do have access to Desmos on the STAR test, and it should be able to give you access to clicking on those points and showing them to you. In your calculator, if you're using your TI Inspire, for this one, I'm going to have to make a guess at that negative 2.5 comma 0, simply because that's not going to show up on the table unless I force it to show up. And it's not, I'm going to have to guess because I'm going to have to zoom in and it's just not going to show me very easily. All right, so I'm going to go ahead and say that my x-intercepts are at negative 6 comma 0 and at negative 2.5 comma 0. If I wanted my graph to be a little bit more precise, I could grab my vertex. That's kind of a nasty vertex. I'm going to leave that one off, and I'm just going to go ahead and graph using my my x-intercepts. I do have two solutions this time, negative 6 and x equals the negative 2.5. All right, so let me go ahead and graph that. 1, 2.5, 3, 4, 5, 6. There we go. And my graph is going to look something like that. Let me see if I can make it go through each one of the points a little bit better. There we go. It's not perfect, but it looks in the spirit of the one that we graphed. All right, so they want us here in the try it to say, in this last one, did you use your calculator to find the exact solution to problem D, or did you approximate? Now, we were lucky because we used Desmos. We were able to find the exact solution to problem D because Desmos did that for us. But if we were to have used our TI Inspire like we did in class, then we would have to have approximated. So it's just a difference between which graphing software we are using. The TI Inspire, we would have to approximate, or our Desmos, which is going to give us that decimal. You even saw it give us the decimal for the vertex. If you are approximating, there is another way that you could actually solve this equation. You could also solve this equation without a calculator using factoring. So let's just go over very quickly the steps, the 4 steps to factor a quadratic equation. The first thing you need to do is make sure that the equation is set equal to 0. If it's not, like it was in our first example here, you need to go ahead and make it, just like we did in this first example. Then we're going to go through and we're going to label our A, our B, and our C values. We need to know what those 3 numbers are. And then we're going to use the cross method to help us factor. In this cross method, you see here on the top that we are going to go ahead and multiply our A value times our C value. And down here in the bottom, we are going to put our B value. And then we're going to go ahead and write our factors. I'm going to give you a little hack to help you find the factors if you can't think of all of them by yourself. Okay, sometimes I miss them and I worry that I miss them. And so I have a little hack for you for how you can not miss any factors every single time. All right, so to solve a quadratic equation, once again, we need to make sure ax squared plus bx plus c is set equal to 0. This is very important that I have ax squared plus bx plus c equal to 0. I'm going to go ahead and do this by factoring. I factor the non-zero side of the equation. That would be this side right here with my standard form, if possible. Then I'm going to go ahead and I'm going to use the zero product property to determine the solutions. The zero product property states that if A times B equals 0, if A times B equals 0, then either my A value or my B value has to be 0. Could they both be 0? Yes, but in this instance, they can't be because if A is 0, then there is no x squared term. So A or B has to be 0. Um, and this means that one of them is equal to 0 and the product of the expressions is 0. All right, the quadratic equation factors into ax plus b and cx plus d equals 0. So what they're showing you here is that you have an x and you're going to add to it your factors. You're going to add to it your factors. What if your factors are negative? What if b was a negative number? Well, then I would add a negative b, which is the same as simply changing this to a subtract b. Same thing with d. So the steps are to set my equation equal to 0 if it is not already, factor, which is what we're going to go ahead and show today, and then we just go ahead and set each factor equal to 0 and solve for the resulting equations and record our solutions. All right, so we're going to go ahead here in example 3, and we are going to find the solutions to our quadratic equation by factoring. Let me go ahead and zoom in here on question A. So the first thing you're going to want to do is draw your line to see if you are equal to 0. We are not. We want to bring everything over here to the x squared side. Everything must go to the x squared side. Whichever side it's on, bring it on over. The only exception is if x squared has a negative, a minus sign in front of it. So if this had been negative, then I would not have moved everything over here to the left side. I would have moved everything to the right side of the function. All right, the 28 is positive, so I will subtract it. It is not a like term to either the x squared or the x, so I'm just going to kind of squeeze it over here at the end. I can also move the 7x at the same time. It is minus, so I'm going to go ahead and add it. This is giving me my 0, right? This is giving me my equal to 0. The 7x is going to go ahead and combine with the 10x because they are like terms. So I'm going to have x squared. Negative 10 plus 7 is negative 3x. And then I have my minus 28. All right, now I'm going to go ahead and I'm going to identify my A term. Remember, your A term is always right here in front of your x squared. This time, since it is invisible, it is a 1. Next, I have my B term. My B term is always right here with, oh, where'd it go? It is always right here with my X. And in this case, it is going to be the negative 3. So B is going to be negative 3. And then finally, I have my plus C term. With the C term, just like the B term, grab the symbol in front, and C is negative 28. All right, now I'm ready to go ahead and factor. I'm going to use my X method to do so. So let me go ahead and make my X. At the top of my X, I am always going to multiply the A number times the C number every single time. So 1 times -2 is, or sorry, -28. Oh, why'd I leave out the 20? The 8 is going to be -28. 1 times -28, -28. And down here on the bottom, down below, is where I'm going to put my B term, which is -3. Okay, I just placed them. Now what I want to do is I want to make a little T-chart. And in my T-chart, hold on, let me see how much space I have. Oh, perfect, there we go. In my T-chart, I want to have one of the sides be a little bit bigger than the other. On the larger side, I want to put my A times C. I want to put the top of my chart, which is -28. In this column, I want every pair of numbers, two numbers that multiply and give me 28 as their value. If I can't think of them all, what I can do is I can go to my graphing calculator. So let me bring up Desmos once again. There we go. And I'm going to go ahead and I'm going to delete this. I'm going to place in here y equals, because I want to graph, right? I'm going to take the number 28. There we go. And I am ignoring that it is actually a -28. I just want the number. I don't care what sign it is, positive or negative. I always want to think of it as positive. And I'm going to divide it by x. My graph is going to look quite weird. And that's fine because my answers for my factors are in the graph, but I want to see them in the table. So I'm going to go to my table. Here we go. And I don't want these negative ones. I want to start here with +1. So I have +1 and +28. So 1 times 28 is 28. I also see right here that I have 2 times 14. So I'm going to do 2 and 14. Now, Desmos kind of stops right there. So I'm going to add 3. 3 times 9.333333 is a factor, but I want to ignore that because I don't want to do negatives. So now I'm going to put 4. 4 times 7 is a factor. The only numbers I have to check are the numbers between 4 and 7. That would be 5, and 6. If 5 and 6 give me a decimal, then I am not going to include them in my factors of 28. So let me go ahead. Nope, decimal. No decimal. And if we click it one more time to add the 7, what we're going to notice, there we go, is that it goes back to 7 and 4. 7 and 4 is the same as 4 and 7. So I am done with my factors and I don't have to write any more down. All right, slide on over, Desmos. Thank you very much. All right, so now I have my factors. On this smaller side of my T-chart, I am going to put the B value, which is -3. Whatever sign my B value has, it is going to go right down this column right here next to it. Always this column because you're always going to put the smaller factor first and then the larger factor second. And so this hack works. So I'm going to go ahead and I'm going to say this one's negative, this one's negative, this one's negative, and then I'm going to go back and look at the sign of 28. Well, 28 is negative. To get a negative, I need a positive times a negative. So that means all of these are positive. It's +1, it's +2, it's +4. +2 times -14 gives me -28. If you don't believe me, please pause the video and check it in your calculator. All right, now what I'm going to do in this final column underneath the -3, underneath my B value, is I'm going to come over and I'm going to start adding together my my factors. I'm going to go ahead and add together my factors. I am looking for the factor that adds to -3. Well, +1 and -28 are going to give me -27. +2 and -14 are going to give me -12. And the last one, +4 and -7, are going to give me -3. There it is. I want it to match. That means I'm going to take these two right here and I'm going to put them into the missing parts of my cross. So I'm going to put the +4 over here, and I'm going to put the -7 over here. Now, one of the things that I do need to be careful for is I do need to watch my A value. If my A value is not 1, there is an extra step that I must do. Since my A value is 1 for this first one, I don't have to worry about doing my extra step. I can go ahead now and write the factors. Remember to write the factors. You're going to put them in that x minus p, x minus q. Here is your p, here is your q. So you're going to just go ahead and say x minus 4, x plus, no, sorry, no. Oh, let me go back. You don't have to change them. It's +4, so you leave it as x plus 4. It's -7, so you write it as x minus 7. You don't have to worry about the p and q. I'm just referring to it because that's what your factor should look like. All right, so your factor is +4, so you're going to put +4. Your factor is -7, so you're going to put x minus 7. Okay? All right, we want to go one step farther and we want to go ahead and solve, right? We want to know what are the x-intercepts, what are the solutions, what are the roots, what are the zeros. So I'm going to take my two factors. This is the A and this is the B that they're talking about. If I'm going to multiply them together and get 0, then one of them has to be 0. So I'm going to say x plus 4 is equal to 0, or x minus 7 is equal to 0. I can solve both of these equations for x by simply moving the 4 and the 7 to the other side. Remember, when doing so, you must do the opposite of what the 4 and 7 are. So our solutions are going to be x equals -4 and x equals +7. Oops, not plus, equals. There we go. These would be our two solutions. All right, let's try another one. And I'm going to go ahead and skip to example D because this one's already, notice it's already set up in the form that I needed. It's already equal to 0. And the reason I'm skipping over here is because, as you can see, once again, the A value is the same as what we had in the first one. So my A value here is 1, and so this is why I'm going to skip over here to this one. Remember, when you're doing this, you want to make sure that you know what your A value is because it is going to affect your answer. There's our B value. This time our B value is 8. And lastly, remember, grab your C value. It is -48. Let me not forget that. There we go. Okay, so now I'm going to go ahead and I'm going to set up my X. Perfect. I'm going to go ahead and I'm going to multiply A, which is 1, times C, which is -48. 1 times -48 is -48. And I'm going to put my B value down below. My B value is +8. All right, I'm going to go ahead and use my little hack. Let me see. I think I have some space right over here. Uh-oh. I have some space right over here. And I'm going to take my A times C term, and I'm going to ignore that it's negative for just a moment, and I'm going to get my factors of 48. Now, technically, yes, it is negative, but I'm going to go ahead and ignore it as I go to place it into my calculator. There we go. Grab my calculator. Just so that you can see it one more time, let me go ahead and show you my little hack. Y equals. So when you use your graphing calculator, you just go into your graph and it already has the y equals part set up for you. You ignore that it's negative 48 and you just type in 48 divided by x, and that's it. There's your graph. Remember though, from the graph, it's a little weird to get the points, so go ahead and make your table. Always start with 1, so 1 and 48, 2 and 24, and then I just want to keep checking, right? 3 and 16, 4 and 12. I'm going to have to extend my table down, it looks like. Now, I already know that 5's not going to work because 48 does not play by the rules of factors of 5. It doesn't end in 5 and it doesn't end in 0. So I know that the 5's not going to work, so I can ignore it. 6, however, works. Notice 6 and 8 are pretty close together. I only have to check the number in between 6 and 8 because when I get to 8, it's going to reverse back to 8 times 6. So the last factor I need to try here is 7. It is giving me a decimal in my table, so I am going to ignore it. And just so that you can see that I wasn't lying, 8 times 6 is the same as 6 times 8, so we are done with our calculator and getting our factors. All right. I needed to add to the B term, which is positive 8. Remember, whatever sign the B term is, all of these factors down this column have that same sign. So these all are positive. Every time, yes. Go back and look. Your A times C is negative. That means one of these two factors must be negative. And since the bigger ones are positive, then the smaller ones have to be negative. We're looking for the ones that add to positive 8. Now, if you think you know which one it is, you do not have to always start at the top. But just remember that you are going to come back and you are going to start adding together these terms. I think it's 3 and 16. So negative 3 plus 16 is what I'm going to try in my calculator. Positive 13. Nope, it's not that one. So now I have to play the game of should I go up or should I go down in my table? I think I'm going to try the one below it. There it is. Negative 4 plus 12 is 8. And I'm going to take these two right here. I'm going to take these two right here and I'm going to place them into my box as into my X as my factors. One goes on one side, one goes on the other. Does it matter? No. No, it does not. All right, now I'm going to go ahead and write my factors. Remember, in the first parenthesis, I simply take the number from over here and I put an X in front of it, X minus 4. The only reason I wouldn't use X is if X was not the variable used in my equation. And on the other side, I'm going to take this factor and I'm going to put an X in front of it. Since it is a positive 12, I'm going to go ahead and make it positive 12. And I have gone ahead and factored. To solve, I need to do that extra set of setting it equal to 0. And I need to take this factor and set each one of them equal to 0 and solve because it's either that or it's this. In actuality, it's this and this, but you get the idea. So I'm going to go ahead and put my line down the middle and I'm going to do the opposite. So I get positive 4. And over here, I'm going to do the opposite, minus 12, and I get X equals negative 12. There we go. All right, now let's go ahead and let's give a try to the to example B. And the reason I waited to do example B is because if you notice, it's equal to 0, that's great, but the A value is not 1 this time. As I'm writing ax squared plus bx plus c, I'm noticing that A is equal to 2 this time. So as I highlight it, I'm going to have to remember that I have an extra step. This one, I have to remember that I'm doing something extra. So maybe just to help remind me, I'm going to put another colored dot right there. I have to do an extra step. All right, B, remember, don't forget to grab the sign in front as well. B is going to be positive 13. Remember, no worries about B and C is positive 21. All right, let's go ahead. I'm going to do the same exact thing that I did. I'm going to grab my X. There we go. I'm going to multiply on the top A, 2 times C, 21. 2 times 21 is 42. So now I want the factors of 42 from my calculator, and I'm going to put the B value down below, which is 13. I'm going to go ahead and I'm going to use my calculator to help me once again to get my factors of 42 that add to 13. So here we go, 42, and they have to add to 13. So let me bring that Desmos calculator up one more time just to make sure that you're good with this hack. There we go. All right. Oops, nope, come back. There we go. Y equals, and let me see my number one more again, 42 divided by X. There's my equation, and I can go ahead and look at my table. Always start with 1. The nice thing about the graphing calculator is that it will start for 1 for you. I must, oops, there we go. I must check, I messed up. There we go. 3 and 14. And so I have to keep checking all these numbers in between. I can't use 4. I know I can't use 5. 6 and 7. There is no number between 6 and 7. The next number after this would be 7, and it just gives me back 7 times 6. So I am completely done finding my factors, and I'm done with Desmos. Thank you very much. All right, this time I don't really have to worry, but I do want you to see that these, since 13 is positive, all these numbers right down here are positive as well. Now 42 itself is positive, so that means my signs must match. So all of these are positive as well. And remember, you don't necessarily need to label that. All right, let's go back through and let's find the one that adds to 13. It's the last one, isn't it? 6 and 7. Let's see. 7 and 7 would be 14. So yes, 13. There we go. It's the last one. And that's fine to do. Or you can come through and say, well, this is 43, and this is 23, and this is 17, and it's the last one. You can always go in order if you like that as well. We're going to take the 6 and the 7, and we're going to place them into our X just like we've been doing. So let me give myself just a little bit more space so you can see me do that. Just as before, just as before. Nothing new is happening here. I'm going to go ahead and do my factors just like I did. X plus 6, X plus 7. However, this time I have to remember that my A was not 1. When my A is not 1, I must take my two factors and I must divide both of them by 2. I'm going to go ahead and put in my calculator 6 divided by 2. Well, 6 divided by 2 is 3. So this factor is going to become 3. It's going to simplify. What I'm doing here is I'm dividing to simplify. If I cannot simplify, then I'm going to do a slide technique. So this factor here is going to become x plus 3. Perfect. Now I factored. Now I'm going to grab my calculator and I'm going to put in it 7 divided by 2. What I'm going to notice is that I get back the same fraction, 7 divided by 2. When this happens, I'm going to pick up that bottom denominator and I'm going to slide it right up here in front of the x. And I'm going to write the factor as 2x plus 7. Now that I have completely factored, I am going to go ahead and set it equal to 0. Once again, why did I do this? I did this because my A value, my A value was not 1. Could I have done this in my A value is 1? Yes, I could have. Let me show you right down here. If I divide by 1 and I divide by 1, I keep 4 divided by 1 is 4, and 12 divided by 1 is 12. So could I do it here? Yes. Is it necessary to do it here? No, right? Because when I divide by 1, I'm not going to change the number of the factor that's here and here. It's not going to change, okay? But when I do not have A equal to 1, it's going to change these factors here. And I must make sure that I have it set up like this before I solve. All right, now I can go ahead and I can take these two factors, not those two factors. Those just help me to get to my true factors. And I can solve for 0 by setting equal to 0, just like we did before each one of my parentheses. And once again, just solving my equation. So here's my first answer, x equals -3. And my second answer, this one's going to take me a little bit more time because this one is a two-step equation. I must first move the 7, and then I must divide by the 2. I'm going to slide it right over here. Perfect. Could you put that one as a decimal? Sure you could. All right, we have one last to do, and I do encourage you to pause the video to give it a try yourself. All right, the first thing you should have noticed is that it was not equal to 0, so you should have moved the 3, giving you this as your quadratic function. All right, then you should have gone ahead and you should have identified your A value. Your A value is 5. I'm going to try this time without putting the ax squared plus bx plus c underneath. Your B value is positive 14, and your C value is -3. Once again, if it helps you write the ax squared plus bx plus c underneath, it just helps to identify A, B, and C. All right, now we're going to go ahead and we're going to do our x method. And in our x method, remember, we're going to multiply our A value, 5, times our C value, -3. 5 times -3 is -15. And we're going to put our B value down here. Our B value is 14. All right, I'm going to go ahead and make my T-chart over here. I think I know the factors of 15. I think they're 1 and 15 and 3 and 5. I think the only other one is 5 and 3. If you want to, I can show you really quickly. There we go. Come on, Desmos. There we go. Let me go ahead and show you really quickly. Uh-oh. Ay. There we go. And let's go ahead and open that up. So 1 and 15, 2 I would ignore because it gives me that, 3 and 5. The only number in between them is 4. 4 gives me a decimal, and then 5 is back to 3. So there we go. I was correct. Now, technically, it is a negative, so one of them must be negative. I'm going to put the C value, remember, over here. This is important because since it is negative, that means the 15 and the 5 are negative, and that these are the two that are positive. I think it's going to be the top one. Oh, no, I didn't want that. No, 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 no. I put the wrong one. I put the wrong number. Oh, no. Let me go back and fix that. I put the totally wrong number. There we go. It's positive 14. So these ones are positive and these ones are negative. The first one is my solution, and they're the ones that are going to go into, these are the two factors that are going to go in. But I forgot to highlight. I forgot to highlight my A, and I forgot to remind myself to divide. I've got to divide. Oh no. Okay, so -1 on this side and +15 on this side. See how easy it is to forget? Right? If I had done that, oh, it would have been catastrophe, right? Because these are not my factors. How do I know? If I do the box method to multiply, right? If I do the box method to multiply, I get x squared and I want 5x squared and it's just not going to work. So I'm going to go ahead and divide both of these by 5, right? Because I want to make sure that I'm dividing by that number that my A value is. So in my calculator, I'm going to put 1 divided by 5. I can ignore that it is a -1 or a -1. I can just put 1 divided by 5, and I can think of that minus as a subtraction. The only reason it would change is if the 5 was negative, but normally your A value will not be negative for you. You're going to get that same fraction, 1 over 5. That means you're going to pick up your denominator and you're going to slide it right here in front, writing your factor as 5x minus 1. Then you're going to go to your other one and you're going to do 15 divided by 5. Now, could you do this in your head and say it's 3? Yes, you could. Since it is 3, then that fraction that you saw, that division problem, is just going to become the number 3, and you're going to say x plus 3. Now you can go ahead and apply the zero product property and you can solve for your two solutions, setting each one of your parentheses equal to 0 and solving. There's my first solution. And if you've noticed the pattern, whenever I have x plus or minus a number, I'm always going to do the opposite of what I see in the parentheses, and that is going to be what my solution is going to be because I'm adding or subtracting from 0. So if I see a minus, it's going to become a plus. If I see a plus, it's going to be changed to a minus, right? And so if you notice that, it's not always necessary for factors like this for you to set them equal to 0.